Assalamualaikum and hi. We are from Group Activators and we will be presenting about Simple Calculator. For the project overview, the Simple Calculator program is designed to perform basic arithmetic operations such as addition, subtraction, multiplication, and division. It provides users with a straightforward way to compute mathematical expression efficiently. This program is implemented using the QtSpim assembly language tool, which stimulates the MIPS processes, allowing users to execute assembly language programs. Beyond the arithmetic operation, the calculator may include additional functionalities such as handling negative numbers, error detection for division by zero, and user-friendly input prompts to enhance usability. These extra features improve the program's reliability and overall user experience.
Let's get into implementation details. Firstly, program structure. We use .data. It contains variables and constant messages such as prompts, which is prompt 1, prompt 2, and prompt 3. Result messages, like result_msg, and error messages, which is div_0_msg and invalid_op_msg. These are stored as null-terminated ASCII strings, which is .asciis. Then, we use .text. It contains the executable code of the program, including main logic for input handling, arithmetic operations, and error handling. Then, subroutines for addition, subtraction, multiplication, division, and displaying results. The program uses system calls, which is syscalls, for user interactions, input and output. Next, key algorithms and data flow. Firstly, input handling. The program uses syscall to read two integers and a single character operator from the user. These are stored in register $$O, $1, and $2. Secondly, operation selection. It compares the ASCII value of the operator using branch instruction, which is back, then directs control flow to the respective operation, which is addition, subtraction, multiplication, or division. Thirdly, arithmetic operations. For addition, it performs using the add instruction. For subtraction, it performs using the sub instruction. For multiplication, it performs using the mul instruction. And for division, we check if the divisor, which is $T1, is 0 using back. If it's true, it jumps to a routine that displays an error message. Otherwise, perform the division using div and retrieve the quotient from the LO register using MFLOW. Fourthly, output formatting. The result is printed with the message result on the same line using syscall for strings and integers. New line formatting ensures the output is clear and readable. Lastly, error handling. Invalid operators print a predefined error message. Then, division by zero is checked explicitly, displaying a specific error message and skipping further operations. Next, register usage. For general purpose registers, $TO stores the first integer input, $T1 stores the second integer input, $T2 stores the ASCII code of the operator input, $T3 is a temporary register used for ASCII comparisons of the operator. $T4 stores the result of the arithmetic operation. Secondly, special registers. LO is used during division to store the quotient. The MFLOW instruction moves the quotient into $T4. Thirdly, system call register. $VO specifies the type of the system call. For example, print integer, print string, print integer. $EO holds arguments for system calls. For example, the address of a string or an integer to print.
Next, I will explain the logic and looping structure in our calculator program. Our program uses a restart mechanism which acts like a loop. After the result of a calculation is displayed, the program jumps back to the main level. This allows the user to perform another calculation without restarting the program manually. Similarly, if the user inputs an invalid operator or tries to divide by zero, the program restarts and prompts the user for new input. The purpose is to ensure that the calculator program continues running seamlessly until the user decides to exit. For conditional checks and branching logic, first one is operator selection. The program compares the user input with the ASCII code of supported operators and branches to the appropriate level. The purpose is to ensure the correct operation is executed based on user input. Secondly, division by zero check. Before performing division, the program checks if the second operand is zero. The purpose is to prevent a runtime error by displaying an error message and restarting the program if division by zero is attempted. Thirdly, invalid operator handling. If the operator entered by the user does not match any valid option, the program jumps back to the invalid label. The purpose is to provide a clear error message and prompts the user to try again. Lastly, result display. After performing an arithmetic operation, the program jumps back to the print result label to display the result. The purpose is to ensure consistent and centralized result display functionality.
Okay, next, control flow and error handling. Okay, first, data section. Data is the section declares initialized data or contents used in the program. Next, prompt1, prompt2, and prompt3. The strings prompt the user for input, which is two integers and an operator. Result_msg, the string is used to display the result of the calculation. div_0_msg or invalid_op_msg which is for error message for division by zero and invalid operators respectively. And lastly, new line, a new line character for formatting output. Okay, next, text section, which is we use two only, .text and .global main. Okay, next, main section, which is include input of first integer, second integer, and operator. The program prints a prompt asking for the first integer. It reads an integer from user input and stores it in register $T0. The same process is repeated for the second integer. The program prompts for an operator and reads a single character into $T2. Okay, next, operation selection section. The program checks which operation to perform based on the operator entered. Each BQ instruction checks if $sign T2 match the ASCII value of a specific operator. If it matched, it jumps to the corresponding label, which is addition, subtraction, division, and multiplication. After that, invalid option section. If none of the operators match, the program displays an error message and exit. Arithmetic option section, it includes addition, subtraction, division, and also multiplication. For division, it first checks if the second integer $sign T1 is 0 to avoid division by 0 errors. If it is not 0, it performs the division and stores the quotient in $sign T4. Division by 0 handling section. After that, displaying result section. This section displays the result of the operation followed by a new line. And lastly, exit section. Finally, this part of the code gracefully exits the program.
Next is user interface UI design. First, prompts for input. The program uses call instructions to display prompts from 1, prompt 2, prompt 3, asking the user for the first integer, second integer, and the operator. After each prompt, the program waits for the user to enter their inputs and stores it in corresponding registers. $sign T0 for the first integer, $sign T1 for the second integer, $sign T2 for the operator. Next is display result. Depending on the operator entered, the program calculates the result and display it with a clear message result value. If an error occurs, for example, division by 0 or invalid operator, the program outputs a descriptive error message instead of producing a result. The third one is user syscalls for interaction. The program leverages MIPS systems calls li $sign V04 to print strings, li $sign V05 to read integers, and li $sign V012 to read a single character for user interaction. Number 4 is user-friendly flow. After displaying the result or an error message, the program gracefully exits instead of abruptly stopping. Then, creative enhancements to the user experience. First one is error messages. Division by 0, the program checks if the divisor is 0 before performing the division. If it is, the program prints a clear error message, error, division by 0. Invalid operator, if the operator entered is not one of the plus, minus, times, or division, the program's outputs error, invalid operator. These error messages guide the user, making the program more robust and user-friendly. Next is descriptive prompts. The program provides clear and specific prompts for each input. Enter the first integer, enter the second integer, enter the operator. This ensures the user understands what type of input is expected at every step. And lastly is special output formatting. The result is displayed with the prefix result, ensuring clarity about what the program has calculated. After the result, a new line character is printed to improve readability.
In this section, we will discuss the key challenges we encountered during the development of our simple calculator program and the solutions we implemented to overcome them. These challenges range from managing control flow and error handling to ensuring a user-friendly interface. By addressing these issues, we were able to enhance the program's functionality and reliability. One of the challenges we encountered is managing branching for different operations, such as addition and subtractions, and ensuring the program flows back to the main loop after each operation. The solution we use is using conditional branching to direct control to specific subroutines for each operation. After completing an operation, the program restarts using a JMain instruction to handle new inputs. The next one is division by 0, handling cases where the user enters 0 as the divisor, which could lead them to runtime errors. The solution we implemented is a conditional check before performing division. If the divisor is 0, the program displays an error message, which is error division by 0, and skips the operation. The third one is invalid input operator, which is managing unexpected inputs like unsupported operators or invalid characters. The solution is we added error handling logic to check if the operator matches one of the valid options, which is plus, minus, times, and divide. If not, the program will output a clear error message, which is error invalid operator, and restarts the process. The fourth one is user input errors, which ensuring the user inputs valid integers and operators in a user-friendly way. The solution is we provided clear prompts and error messages to guide users, ensured user feedback is consistent through descriptive messages and formatting. And the last one is output formatting, which is making the results and errors visually clear to the user. So the solution we use is syscall instructions to format result and error with appropriate spacing and new lines for readability. So finally, we will share our conclusion summarizing the valuable lessons and insight gained throughout this project. The Simple Calculator project was an enriching experience that strengthened our understanding of assembly language programming and system-level architecture. By developing a program that performs basic arithmetic operation, we successfully implemented concepts such as register usage, control flow, and conditional logic in the MIPS assembly language. The key takeaways from this project included practical application, which is translating high-level programming ideas into assembly instructions, help us grasp the nuance of low-level programming. The second one is error handling. Implementing robust mechanism for division by 0 and invalid operator input emphasized the importance of anticipating and managing users' error effectively. And the third one is programming logic, which is managing looping and branching structures reinforce our skills in designing efficient program flows. I
Additionally, the project helped us appreciate the value of clear user interface design and well-structured error messages in enhancing user experience. Overall, this project not only deepened our technical skills but also improved our problem-solving and debugging capabilities, leaving us better equipped for the future challenges in computer organizations and architecture.